Cool. And we're live again. So I hope you had a good short break. And so welcome again to our final session, which will be on publishing data. And I can make this maybe a bit bigger. Okay. Right. So in this section, we want to talk about how you can actually publish your data and share your data sets with people and collaborate on data sets. And so you did all your nice version control and used containers and created your script and your results and awesome figures. And now you want to bring it out into the world. And now actually, thanks to DataLad, you can make use of a wide range of different types of hosting service and storage solutions where you can put your data. And in this session, we want to highlight a couple of workflows that you can use to publish your data and collaborate with other people through these platforms, and go through one particular workflow that is especially geared towards resources we use at the MPI in Berlin that can be used by you for your next DataLad project as well. So just to, as a general introduction, in general, if we think about data, we would like to be in a position where we can share data just like source code. So maybe some of you have used Git before or have used GitHub before to share code with other people or just back up their own code basically. And we actually want to be in the position to do the same thing with data and also use the DataLad and Git infrastructure to do the same like we do with our source code. And just like kind of regular code in a Git repository, datasets can also be cloned and pushed, updated from and to local path or any remote hosting service or other external special remotes. So you can see some of the relevant DataLad commands here. So usually you have the data set on your local machine or maybe on your compute cluster. And then you want to publish to a different place, which could be GitHub or GitLab or some other hosting solution. And there are, like I said in the beginning, a variety of different storage solutions like Dropbox or Google Drive or Gin that we briefly talked about in the beginning. And so there are different data commands that can be used for that. Like, for example, the DataLad publish command, which, like Adina pointed out, is a slightly older command, which nowadays is called DataLad push. And in the DataLad language, just to also not get confused, in the DataLad language, when we talk about remotes, so instances of our data set that exist in a different place other than our local workstation, are called siblings. So you will notice that sometimes we use these terms sibling and remotes interchangeably, and I'm also happy to be corrected if that's actually not true, but that's how I always understood siblings and remotes. And likewise, to consume data, not only to publish data yourself, but to consume data from others, there are a set of other commands, like, for example, the DataLad clone command that Adina showcased before, where you can clone a data set from a remote repository, and the DataLad update command that you can use to update your data set. For example, like Adina nicely showed, when the input data has changed and you want to get the most recent version of the data set. You have with DataLad, you have this flexibility to have different types of access options and store your annexed file context on different types of storage solutions and storage locations. And the great thing about DataLad is that DataLad is really built to maximize interoperability. That means you can really make use of different hosting solutions and storage technologies, and can even use them at the same time. So you don't necessarily need to decide for one storage solution in the beginning, but you could, for instance, start with one storage solution, but then move to a different storage solution, or use a set of different storage solutions at the same time, and always push updates between these different data sets. Exactly. So for example, just to explain what some of these logos were, to be super honest, I actually don't know all of these logos myself, but you might spot several of them, like Fixture at the top, OpenNeuro, a very common platform to host neuroimaging data, GitLab, Dropbox, the OSF, Gin, or even Google Drive, GitHub, etc. All right, so let's get a bit more into the details and concepts of publishing data. So usually it would start like this. You create a data set on your computer. So at some point you will ask yourself, how can I share it or collaborate on this data set? So down below here, you can see your data set on your workstation or some server that only exists locally in one place. So a general distinction that is important to understand when using DataLad for publishing is that there are repository hosting services like, for example, Bitbucket, GitLab, GitHub, or Gin. And then there are third-party storage providers like the ones you can see on the right, like Dropbox, OSF, etc. And exactly. And the important distinction here is that most public data sets that you will encounter or maybe publish yourself will have separated the contents that are stored in Git and the contents that are stored in Git Annex behind the scenes, or you make this explicitly or make these choices explicitly. So in general, exactly. So in general, the content that is stored in Git, and just to remind you what this includes the dataset history, commit messages, run records, all the files that you committed into Git. Usually this will include all the code that you have in a data set, files that you didn't put into the Git Annex, like, for example, identity hashes, storage locations that, like it's said here. These information will be shared through these repository hosting services. And these repository hosting services, they usually don't have Annex support, so they can store these Annex files, which are usually these bigger files that you have in your data set, or can't really hold this data or this larger data for free. Instead, what these repository hosting services do, they can nicely show this Git history and all the files that are stored in Git, and also show you how datasets can be cloned and thereby consumed. So in contrast, the Git Annex content that goes to a different location are all the files that are stored in the Annex and are organized in this object tree, Git Annex object tree of the dataset. So if to make this more concrete, if you think about MRI data, for example, usually all your MRI data will be annexed, and this data will not go to GitHub or GitLab or one of these other repository hosting services, but instead will go to one of these storage solutions here on the right. And these storage hosting solutions, they usually don't have Git repository support, so you don't have a nice interface or website like GitHub that you can go to where you can see kind of the outline and the structure of the repository. But they really only store this object tree with file contents that actually looks a bit weird to you, because it's like weirdly named folders and files, and you can't really make much sense of it without knowing kind of what it is and how it relates to your data set. Importantly, DataLad keeps track of where the data is stored, so on which of these storage hosting services you put your Annex data, and this DataLad get command that we talked extensively about before, this can then retrieve these file contents from the special remote. So then you have it all again in one place. All right. Exactly. So just to make this typical case more clear, so the data set itself is usually exposed through a private or public repository on the repository hosting service. Like I said, one of these services like GitLab and GitHub, but the data can't be stored there, so it's kept in any of these third-party storage solutions. And importantly, what comes up here in the middle now is also an important concept concerning the question how these two things are actually linked. If they are separated, how do you kind of keep this link between them? And you can configure what are so-called publication dependencies. So when you push the data and you have set a publication dependency, then DataLad in one go, in one push, will push the information about the repository to the repository hosting service, and at the same time push the annexed contents to the data storage solution in one go through this publication dependency. So the publication to GitHub, for example, depends on a simultaneous push to your storage solution. And we will make more clear in one of the workflows how this is done exactly. Exactly, there we go, publication dependency. One way to configure such a publication dependency is by using the git config command, and then in your remote that you configure, so the hosting service that you use, to configure a DataLad publishing dependency. In this case, for example, G drive. Another way, did we include here? No, is you can specifically configure the siblings by a DataLad siblings command, which we will show later when we showcase one of the workflows. All right. Do you want to say something about that, Adina?
Yeah, that's just to illustrate how the what you nicely explained as having all of this set up in the background or behind the scenes is completely visible to whomever consumes your data sets. Once you have all of this configuration set up, it doesn't matter whether your data lives on a web server, lives on G Drive, lives in the Open Science framework. A DataLad get retrieves the files if you allow a specific user to retrieve a file from wherever the data actually comes from, and there's no need to know where that is. As a provider of a dataset, you can make sure that it always works. So if you clone, let's say, any of the OpenNeuro datasets that are exposed via GitHub, their data actually lives on S3 buckets. This dataset that we're cloning there, I think, lives on a web server somewhere. And yeah.
Exactly. So in this case, like Adina said, for this particular dataset, the data is on server. It's very easy for public repositories. Like Adina said, you can configure everything in the background so that a consumer of your data set can easily get the data. Sometimes, at least I noticed this, for private repositories, it can be a bit tricky and you need to invite people to certain storage solutions so that they can then access your data. But we will show this later in one of the example workflows. Exactly. So do you want to say something about this? Sure.
You go, sorry.
Okay, no worries. So there are some special cases that we discussed in the beginning. Also, someone asked earlier about the hosting service Gin explicitly. So there are some repositories that have Git Annex support, for example, Gin and also the Open Science Framework. So they can basically do both. So like I said in the beginning, usually it's separated, the repository hosting service and the storage solution. But some of these services provide both. So for example, Gin can is a GitLab instance with enabled Annex support. This can hold both your repository and your data for free, thereby also expose not only the Git history, but also the actual Annex content that you can also view, for example, directly through their web interface, and datasets can be directly cloned from there.
And it's German servers. So if you have data usage agreements that require you to publish the data only on German servers, then that may be a really, really, really easy solution where it's there's a GIF later that shows how it's done. It's just a couple of clicks and a couple of commands, and then you can publish your data. And Lennart has, like the very first time Lennart and I got in touch, we took 20 minutes to publish 500 gigabytes of his neuroimaging data to Jin, I think.
Yeah, exactly. And Michael in the chat already pointed out earlier that it's actually very cool, this Jin service. And at the moment, it's still free. Let's hope that this doesn't change in the so near future, and we can all publish loads of data to Jin. All right, so what's about this? So yeah, so for example, you can also publish both components to a special remote. There are specific DataLad extensions, for example, the DataLad OSF extension that can push the Annex contents and the Git history to OSF. And in this case, the Git repository will be published in conjunction with the annexed files. And then you can clone directly from the special remote. And OSF is a good example, and which some people might also know and use.
Can probably quickly walk through this, because that just highlights how easy it is to publish to Jin. So what you can see on the lower hand side is that I went to gnode.org and created a new repository. And in this terminal, I have created a new dataset and added a comic and just did some annexed contents. When I take the SSH URL of that Jin repository and give it to a DataLad siblings add command, where I supply a name as Jin and the URL, I can add this Jin repository as a sibling dataset. And with a single DataLad push to that sibling, I not only publish the Git aspect, but also the annexed data of the dataset. And if I reload this web page, then you can see that the complete repository, including the annexed content, is there. And because Jin has fantastic web rendering, it even displays PDFs, PNGs, and so forth that you have annexed and pushed there right there. So if you want to publish data and you want to really just be fast and quick, then you can use Jin. It's super, super awesome. Later, the publication routine that Lennart and I will showcase is more complex, and we wanted to highlight how you can make existing infrastructure work, even though if it isn't as easy as on Jin, but still very doable. And if you click one slide further, then I can also walk through the OSF slide. So let's say you want to also publish to the OSF, because Open Science Framework is frequently used. You can install DataLad OSF as a DataLad extension, and then use the DataLad create sibling OSF command with the title, here it's comics, and a sibling name. And that will create a new project on the Open Science Framework under your user account with the title that you've given it. And it configures a publication dependency per default on this project. And if you then do a DataLad push, then it will publish your Git history and your annexed data to the Open Science Framework. If you do it in the default way, you will get a non-familiar view of the dataset, which is due to that being a non-Git repository hosting service. So if you push and then reload the web interface, you will see that there is a .git directory and that there is an object tree that is this character hash that you have seen in the sibling that I've shown before. That is actually that comic. So that view is untypical. You will see how it will be a normal view again once you clone that. And I also want to highlight, and I've pasted the documentation with tutorials into the chat, that there are other modes that you can use the DataLad create sibling OSF command with, that, for example, can create a snapshot of the dataset that looks just like a dataset on OSF. And if you're interested in using the Open Science Framework, then the DataLad OSF documentation has tutorials. And I also want to shout out the awesome people that did this, because we hacked together the extension, the DataLad OSF extension, during the OHBM hackathon during 3 days, in which none of us slept, I think, but there were 8 really motivated people from all over the world that just took DataLad and extended it to work with the Open Science Framework. And that's so if you have another storage provider which you would like to use, then it may be actually doable to just implement it in the form of a DataLad extension. And if you open up an issue on the DataLad GitHub page and just tell us about your needs, then maybe there is another hackathon where we can just make it possible. Okay, yeah.
Cool. Thank you, Adina. So now we just briefly want to talk about what cloning of DataLad datasets means, and how cloning datasets feels like for a consumer. So one very simple way that you can kind of clone datasets is just also on your local machine. So you can on your local machine you can clone datasets from any other location on that same system, and then also get the files from this local path. That's very simple, and you don't need any third-party storage solution to do that. But then there's an explicit link between these 2 locations on your local machine. You can also clone from a server or cluster, which depends a bit, I guess, on the cluster solution that you have. But you can basically provide the path or would you say URL to the to your cluster, and then DataLad get files from there. Maybe to mention here, so with our cluster, I did this maybe a bit effortful workaround to push to some remote repository and then clone back to our cluster, but that also works. So basically going through some third-party storage solution. But that's actually neat, because then you can very easily prepare a dataset on your local machine and maybe write some code that is supposed to run in the cluster. Then you push your dataset to the cluster and can send off your jobs that are happily running there. And then you can save the content and clone back to your local machine and then continue with whatever you want. All right. Then the next step would be cloning from a remote URL. So in this case, you would consume a data set that you found, for example, on GitHub or GitLab, or that you know of. And you can, again, use the DataLad clone command and provide the URL to the repository. Adina has shown this to you today multiple times. And if the dataset is configured properly, then with the DataLad get command, you can automatically get the annex contents from whichever storage solution this particular dataset uses. Sometimes it depends, it may need some additional configuration, but hopefully the people who provide the dataset also provide this information to you, at least in some README, if it doesn't work out of the box, so to say.
Yeah, here's another look at those special cases where I just wanted to showcase how cloning from Gin and OSF looks like. Here I'm logging into our cluster so that I'm not cloning to the same computer I created it on. But on Gin, it's a DataLad clone with the URL that I can copy paste from the repository. If I take a look into the dataset contents, I have the comic that's not there, and the DataLad get retrieves it right from Gin. super, super fast. Note that I'm using SSH to do this, and that would require a user account, but you can also do HTTPS, and there's a tutorial that I've pasted in the chat that demonstrates that thoroughly with anonymous HTTPS access. And if you could click to the next slide, there's DataLad OSF, where it's a little bit different. So in order to clone a repository from the OSF, you need the DataLad OSF extension, and you give it a weird type of URL, which is OSF : / and then the project the project ID of your project on the OSF. And then you can clone that from this particular special type of URL into hopefully a different path that you provide so that you have a readable data set. And when you then take a look into the data set, then you have your familiar view. So although it looks weird in this type of storage sibling that we have created at the Open Science Framework, once you clone it, it looks completely normal again. And then you can retrieve the data with the DataLad GET also without any problem. But there are also, so if you're using the Open Science Framework frequently, there are other modes that you can use the Open Science Framework, and I encourage you to just check it out whether there's something that suits your workflow. So if you want to showcase data in not an object tree, then you can also just export the data in a view that is more familiar to the people that you work with. Okay, thanks.
Thanks. All right, and now we're gonna talk about a specific workflow that is geared towards resources that already exist at the MPI Berlin. But for those of you who are not at the MPI Berlin, don't worry. Like, it's a very similar workflow can also be used if you want to configure any other storage solution. And in this case, we are going to share data via Seafile, and Seafile is essentially a cloud storage solution, very similar to Dropbox. And in this workflow, in this demonstration, we're going to show you how you can set up a very easy collaborative workflow on data with DataLad and share your data through this storage solution. So, and this is also meant a bit as kind of demonstration to wrap up some of the commands that you noticed before. So the first step, if you remember, is to create a new DataLad dataset. And you may have noticed throughout our workshop that we really like cartoons. So of course, the example is a dataset where we create a cartoon collection. And you can see the common DataLad create command that creates a directory on my desktop called cartoon collection. And I go into this directory and use the wget command that you also already know to download an XKCD comic. And I save it to the DataLad with a helpful commit message. And now I'm wondering, I have this cartoon collection. I mean, it's only one cartoon yet, but this cartoon is actually already quite funny. So I really want to share it with my friend Adina. How am I going to do that? So now I need to think about how to publish with DataLad. And I know that my institution, the MPI or the Max Planck Society in general, has a very cool service that I actually only recently learned about, which is Seafile or Keeper. So Seafile is the storage solution and Keeper is the name they give it. And Keeper offers 1 terabyte of flexible storage to all Max Planck employees. And I was a bit shocked when I heard it for the first time, because that's a lot of storage space that one can use, and I didn't know about that. So there's the footnote, even if you don't end up using DataLad, and I would be very sad if this would be the case, but nonetheless, even if you don't end up using DataLad, make sure to get those 1 terabyte of storage space and then do whatever else you want to do with it. It can be essentially configured like Dropbox, so you can also use it in that way. And also the data on Keeper, because it's a Max Planck service, it's stored on Max Planck servers. So also your data protection officer will be pleased because he or she knows that your data is in a safe place. All right, so I'm want to share via Seafile. So let's take a look how this is done. So first of all, you need an account for Keeper or Seafile. That's very easy. You can just register with your MPI credentials. Then we also know, because I showed you in the beginning, that with DataLad, usually the repository hosting and the data hosting is on 2 different locations. We want to create a GitHub or GitLab repository to host the metadata and all the content that is not stored in GitAnnex. And then to work with Seafile and actually other storage solutions, we need to install another tool called rclone and the GitAnnex remote rclone wrapper to make rclone usable with GitAnnex. And DataLad uses this rclone tool to kind of transfer or push data to this Seafile special remote. And we won't go into details how you can install these things. They are documented in the DataLad handbook, how to install rclone and the GitAnnex remote rclone wrapper. And this is might also be platform specific. So we won't go into the details of the installation here, but just showcase the workflow in general. Okay, this should be pretty known to you at this point. So you can just create a new repository on GitLab, for example. So this here is a screenshot of the local GitLab instance of the MPIB. So I create a repository called comic collection, and I can decide if I want to make it public or private. I can do the same thing on GitHub. This is a screenshot of how it looks on GitHub, but it looks very similar, as you can see. All right, so first I'm gonna configure this rclone remote to use with DataLad and Seafile. So if I type rclone in my rclone config in my terminal, I can select to configure a new remote by pressing N. Then I give this rclone configuration a name, and since you're configuring a Seafile remote, it's a good idea to name it Seafile or Keeper if you want. So I chose Seafile in this case. And then rclone would show you different options for storage solutions that you can configure in this rclone configuration. And you can see here I actually had to truncate the list of all the different storage solutions that are possible to configure with rclone. You can see in the list, for example, Dropbox, Amazon Drive, and actually the very last option, option 38, in fact, is Seafile that I then select. And as a next step, the rclone configuration asks us to enter the URL of the Seafile host. And in this case, this is just the regular web URL of Keeper. So I include it here and press enter. Then I enter my email address, so the one that is associated with your Keeper account. Obviously, you should enter your email address and not mine. And you need to provide a password, which I'm not going to show you. And then there are several other options. So you can enable 2-factor authentication if you want to. I don't do it here. Then there's a kind of tricky or part to watch out for. rclone asks you to enter a library name. So this is the name of the library as it will show up on Keeper. Think about it as a regular folder on Keeper, similar when you transfer data with Dropbox, for example. There's a folder in your Dropbox account. And we actually don't give it a name here because we want to just configure one rclone remote for our Seafile or Keeper account that we can then reuse across projects. And I'm going to show you in a bit how this works exactly. So at this stage, we don't provide a library name, so we just leave it blank. We can actually encrypt the library if we want to make things super safe. For my cartoon collection, I don't really mind, so I don't enable encryption here. You can just press enter. All right, then comes the last interesting bit, which is the advanced configuration. So rclone asks you if you want to edit the advanced configuration, and you press yes. And then rclone asks you if rclone should create a library if it doesn't exist yet. And in this argument, you set to true, and this relates back to the comment I made earlier about the name of the library. So here, when you set this option to true, then if you push data to Seafile via this rclone configuration, rclone will automatically create the corresponding folder on Keeper for you, which then means that you can reuse the same configuration for a different repository, and rclone will then generate or create a new folder on Keeper for this other project. Then there's one last bit about the encoding, which we can just keep at the default value and don't worry so much about it. And we're done. That was easy, right? So we get this summary of the rclone remote that we configured, and also a list of the remotes that we configured overall. So in this case, it only lists one remote, namely the Seafile remote. And don't get confused, because we named the remote Seafile, and the type of storage is also Seafile. So that's why Seafile comes up here twice. If you're a bit impatient, then you can also do this in one go, basically in one line of code with all these arguments. And actually now I'm exposing my password to you. You can try if it works, maybe not. But this is basically the same configuration, just in one line of code, and you don't need to go through all these steps, whatever you prefer. All right, that's about the rclone configuration. So then what's kind of remaining is we need to initialize this rclone special remote that we just configure. So this configuration for now just exists on your local machine, and we need to initialize it for our data set. And for this, we're going to use this command, which is also documented in the DataLad handbook, which is the git annex init remote command. And we give it a name, and this name, again, it's a good idea to name it the same like the rclone configuration. So we again name it Seafile. The second line of code is our kind of default values. So it's an external storage type and without encryption. The target, this target argument specifies the rclone remote that you just configured. And remember, we called it Seafile. So again, you need to put Seafile here. If you named it differently, for example, Keeper, then you would need to put Keeper here. And finally, we set a prefix, and this is the name of our data set. And this will be the name of the library on Keeper, where Keeper will push the annexed content into. So this relates back to our previous settings that we allowed rclone to create a library on its own, and also where we didn't specify the library name. Because by specifying the prefix here, when we push to Seafile, rclone will automatically create this library on Keeper for us, and we don't have to do it manually. Exactly. And like I said before, it's helpful to be consistent with the naming, to not be confused. And I told you about the prefix. And then we can see kind of the output of this operation, init remote Seafile OK, recording state in Git. And if we use the DataLad, DataLad siblings command, you can see that there are two siblings or remotes configured for this data set. So kind of locations where DataLad knows this data set exists. One is here, the location on your local computer, and the other one is Seafile with our clone as the service that we use to publish our NX content. All right. So before we talked about this publication dependency and that we need to make sure that the structure of our repository is published to our repository hosting service like GitHub or GitLab, and that the NX content goes to our storage solution, in this case, Seafile. So now we need to add the GitLab or GitHub sibling or remote. And that's very easy with DataLad as well. So in this case, we use the DataLad siblings command, and we do DataLad siblings add. Then we give then we specify the name of this new sibling. In this case, I chose origin. We provide the URL. In this case, I'm using the SSH URL to the GitLab repository that I just created before on the GitLab website. And here we explicitly set this publication dependency by adding this -- publish depends Seafile, which is our rclone remote. And you can see some output, and then you can see that this Seafile or that the GitLab origin sibling was configured correctly. And when we do the DataLad siblings command again, which lists all the available siblings, we can also see this origin appearing here. If you wonder about the plus and minus you see next to the siblings, that basically means if the remote or the sibling has NX support or not. And we know that locally we can have our NX data. On rclone we can have our NX data, but the origin on GitLab is just the repository hosting provider and does not have NX support. Short quiz question. Why do you think did I name the GitLab sibling origin? I'm actually not going to wait for answers. I'm just going to tell you the solution directly. If you clone a repository from, let's say, GitLab or GitHub, you may have noticed before, if you, for example, use Git before, that the name of this remote in kind of Git language is usually called origin. So basically, when I create the sibling in the first place, I already name it origin and not something else, because if I later clone to a different location, no matter which name I gave it, now when I created the sibling the first time, it will, if I clone it to a different location, it will again be called origin, since this is just this Git standard. And even with this local version of the dataset where I configured the sibling the first time, I don't want to be confused with these with these sibling names, so I just call it origin in the first place. All right. So finally, we did all this very exhausting and extensive configuration, and now let's see if we're rewarded. So finally, we can push our data, and so we do DataLad push, and we specify the sibling that we want to push our data to, in this case, origin. And remember, we set the publication dependency. So what happens is the DataLad is so super smart. When we push to origin, it will push the repository contents, like our Git history, all the stuff that we talked about before. It will push this to GitLab, and copy or push the NX content, in this case, the XKCD comic that I added to the repository at the beginning. It will push this to our Seafile remote and store the NX content there. And we can see that it worked. So that was successful, and we're super happy about this. And also something to keep in mind is that I didn't talk about collaboration yet, right? this was just a step to push my dataset or my annex content to a different location, which also means that I've just created essentially a backup of my dataset, right? So if there would be a fire now, or I would lose my laptop, if I would be like the poor chemistry student that lost his or her laptop, then I would now have a chance to retrieve my precious cartoon collection from Seafile or GitLab or vice versa by just cloning my dataset again, and I have all my data back. So remember, in case of fire, always push your data first and then leave the building. Obviously, that's not like legal advice, and you didn't hear it from me. Exactly. Remember the poor chemistry PhD student. All right, we can also check out all these web pages. Like at the top, you can see the Keeper library, and you can see, yay, the cartoon collection is there. Actually, if you go click inside the cartoon collection, you can see this weird folder 510. What does it mean? That's actually the Git annex object tree that is then stored in this cartoon collection library on Keeper. Keeper has this weird habit or algorithm to automatically add a markdown file and a PDF to every library, which contains super useful information how you actually use Seafile. Once you've seen it for the 20th time or so, you will just delete it, which I usually do manually. I don't know if there's a way to not have to do this manually, but it doesn't affect your data, so you can also just leave it there. It doesn't hurt. And we can check out GitLab, and you can see here that on GitLab, you can see my push. So add the funny XKCD comic, and we can see the structure of our repository with our first cartoon. Great, we published a data set to a special remote. Excellent. All right, but remember, I'm really only doing this to be able to share my cartoon collection with my friend Adina. So what would the person whom I'm sharing the data set with would have to do to get this, get the files? So Adina will go into this in a bit more detail from her perspective. I'm already foreshadowing here, and you can maybe also imagine yourself at this point that it would first involve cloning the data set, and I want you to pay special attention to one output of this DataLad clone command, which is this here in line 5 and 6, where data tells me that access to one dataset sibling is not auto-enabled, but we can enable it with this command. So basically, DataLad tells us, hey, there's a special remote, but you need to enable it first. So, and as you can imagine, to be able to enable the sibling, Adina or any other person whom I want to share this data set with would need to, first of all, have access to the contents on Keeper or Seafile, and then also enable this special rclone remote using the same configurations. And then this person can enable the Seafile special remote for this repository and get the annex data. So maybe just to show it to you how enabling access to Keeper works for other people. In this case, it's also interesting because Adina is not at the MPI, so but I can still share the data set with her, which might be relevant if you are collaborating with people that are not at the MPI or in the Max Planck Society. So you can simply go to the Keeper website and to the repository, and there's a share button somewhere. You can't miss it really. And there's an option to share to user, and I just typed in Adina's email address, and she will get a notification. To enable her to also push to the repository, I obviously need to set read-write permissions. And that's one prerequisite that I need to do. And from that on, Adina can take over to demonstrate how this looks at how this looks like at her end. Do we want to switch the?
Yeah, probably. I'm taking the presenter from you. And I'm going to show you what I had to do from my perspective, and it was actually a very fun exercise. So Lennart, first of all, shared the special remote in the repository with me. So he's just shown you how he shared the Keeper library with me, and I received an email that conveniently told me, hey, there's a member of the Max Planck Society that has shared data with you. And then I can log in, which is a fantastic service actually from the Max Planck Society, and see the cartoon collection, the library, in the libraries that he has shared with me. And he also sent me a link to his GitLab repository, so that I knew where to go to in order to get the appropriate repository from. The first time we did this, it was actually quite funny, because he wrote me a cryptic email with, I challenge you to retrieve this annexed file, without telling me anything else. But pointing to a Git repository, which was a fun thing to do. But here he essentially told me everything that I needed to know. He told me that there is a Keeper library and that there is this Git repository on a GitLab instance, and that he has named his rclone remote Seafile. So what I initially did is I started with cloning the repository from GitHub. And as Lennart already showed you, I got the repository, and I could list the contents of the repository, so this PNG, but at this point it's just the identity information. It's not actual file content. That file content is on Keeper, and I get a DataLad siblings enable command that is tuned to my file system, so when I copy paste this one, then I can enable the special remote but just by copy and pasting it out of it. The important point for me in this setup, where it is quite so there are other ways to do this kind of publication routine. We have just fitted it to what is available at the MPI infrastructure. There are ways to make this even easier, but in the case of the external Keeper remote, there I actually need to configure the rclone software myself to have that pointed to this storage provider. So I'm just configuring exactly the same rclone remote as Lennart did. I'm configuring a new remote. I'm naming it Seafile, just to have the exact same name. That's actually an important thing to do. I choose Seafile. I enter the Keeper address of the MPI. I use now my personal email address to enable rclone to look into the libraries that I have in the Seafile instance and input my password. I also don't want two-factor authentication, and I also leave the name of the library blank in order to have the same configuration, because probably Lennart and I will collaborate in the future. And with that rclone remote set up and configured, he and I can create dozens or hundreds of other repositories and can then just get them to work right away without an additional rclone configuration if we have such a setup. I thus also added the advanced config. I set create library to true. I pass on encoding, and I have a configured Seafile remote that almost looks identical, with the exception of my user and password, as a configured rclone remote. And as a small tip, Lennart shared how to do it in one line. I'm going to share how you can do it as a text-based thing. If you're on a Unix-based operating system, then rclone saves all of these configurations in a file in your home directory in the .config folder. It's hidden, but you can just take a look at it as in any other folder. It's where a lot of files just save their configuration files into. And there's an rclone directory with an rclone conf configuration file where you can just write down the configurations in a text editor if you want to. All right, so rclone is a fantastic software in itself. So if I, let's say, do an rclone LSD to list available directories in this configured remote C-file, then it can already show me that there is this directory cartoon collection, Adina, that you have been granted access to and that you are now able to retrieve data from. So now it's actually time to get the comic. So first, I'm going to copy and paste the DataLad siblings command, which enables the C-file remote in my clone of Lennart's dataset. And then I can get the comic, and success, I can take a look at the comic, and Lennart has successfully shared the data with me and I was able to retrieve it. And that can be a comic, but that can also be his most recent neuroimaging study or mine. Now, what I, at this point then thought, that's a cool comic. I really like that one. I even have it on a t-shirt. But man, I also know some other cool comics. So let's go from sharing data to collaborating. And we want to take this workshop to showcase one collaborative workflow that is borrowed from the way that software development uses collaboration. If you have never used GitLab, GitHub, or such repository hosting services, or Git in a collaborative fashion, then this can be a little bit overwhelming. But in my personal opinion, it works well if you use it or hear it once. And then if you read up on it and just digest it for a night, everything becomes much more clearer on the next day. And at one point, it will make sense and be very beneficial if you incorporate it into your own workflows. So sorry, I'm going to hand, do you want to talk? I'm just clicking.
I think it's not much. Actually, it's still on your side of the collaborative process, actually. Maybe just to mention here, so if you want to collaborate with someone, and this might be especially important in cases where your data set is maybe still private because you want to keep it private for some reason, then you need to kind of manually add your collaborators to your repository. In this case, I could just go to the settings of the repository on GitLab and add a new member to the repo. Again, I just entered Adina's email address and gave her, you can set certain role permissions, so at which level people can access your repository and the things they are allowed to do. And I really trust Adina, so I gave her developer rights. And also, I shouldn't forget to also add her to as a collaborator to the C-file or Keeper library, as I showed you before, which you need to do through the Keeper web interface.
All right, so I'm going to walk you through a typical collaborative workflow that makes use of the features that repository hosting services provide and of the functionality that the version control tools in a DataLad dataset provide. As a heads up, that's a workflow borrowed from software development that, in our opinion, is really, really beneficial for scientific collaboration, because with everything that you're doing, you leave a digital trace of what has been done. So a typical collaborative workflow starts with an issue. An issue is a feature that is provided by the repository hosting services. And that's a very nice way and good practice to keep your collaborators up to date on what you're planning to do or on what kind of problem you're facing. It's a way to give them a heads up and to seek input or feedback or have discussions out in the open, or if it's not a public repository, in a private repository, not so much in the open, but at least in a place where it's publicly documented, attached to your project, and record for future yourselves. And therefore, I go to GitLab and I tell Lennart, hey, thanks so much for sharing your comics with me or your neuroimaging data, but I think I have some additions that I can make to this. So how about me adding some? I can do a pull request. And Lennart can then get an email about this issue and say, cool, that would be great. I'm looking forward to your PR. And I can be confident that my contribution is worth it. And I work towards adding content to this repository. So now up for collaboration. The first step that I'm doing, and that is something that looks weird on first sight, but it's something that you get used to quite easily, is you create a new branch in the dataset. And Lennart has already introduced this concept of a branch a bit. And it is good practice to do so and it also comes from software development, where you not usually develop a new feature or add code or add data in the same development line that is the master or main branch, so the main development line. That makes it easier to incorporate changes with a trace of where they came from. That enables easier parallel development. And in many cases, for example, with GitLab, it is also necessary, because in the case of GitLab, the master branch is what is called write protected. So I actually need to create a new branch because I can't push directly to the master branch. So it's quite easy. Sorry. It's quite easy to create a new branch. One way to do is with the git checkout-b command that creates a new branch. In this case, it's called more comics, and also checks it out so that I'm on top of that branch and can make my changes. And then I can add the changes that I want to do. So in this case, get another comic and save it. And now it's my turn to push back to the Git repository that has been shared with me. And because I don't want to do two separate DataLad push commands, but I want to have it as easy as Lennart had it when he configured a publication dependency, I'm going to do the same just to spare me the two pushes. And for this, I'm taking another good look at the siblings that I have. It's origin and Seafile. And I'm using here the git config command as an alternative to what Lennart has shown you with the DataLad siblings command. And I configure that publication dependency in my local dataset, where that line of code basically translates to, when pushing anything to the sibling remote origin, push changes to the sibling C file first. And once that is configured, so here's another overview, I can do a one-time push. Because I've cloned from an HTTPS URL, I actually need to authenticate with my username and password. So this is why I typically use SSH keys. And then it uploads the Git history, the commit message that I attached, the history of my contribution to the repository, and it updates the C file library with the new comic. And then I can create what is called a merge request, which is the software development way of proposing a change for integration into the main feature development line. And that is very, very well applicable to science. So if I now go back to the repository hosting site, then GitLab very, very handily tells me that you pushed to the branch more comics at this repository. How about you go and create a merge request with the changes that you have pushed? And I can quickly and simply push that button in order to enable such a merge request. It gives me the option to add a title and a description of what I've done. And once I do this, Lennart gets an email and can check out whether he likes my contribution or not. And if so, he can merge it and integrate my contribution to his repository. Okay, I'm handing over to you. You should be able to screen share now.
Sorry, I was still muted. Can you see it? Yeah. All right. So actually now that I enabled my collaborator Adina to work with me on the data set, I got a notification that she contributed a merge request and proposes some changes to my data set. So now, as kind of the maintainer of this data set, I need to review the changes and see what Adina is proposing there. So I can do this again through the terminal. Like one command that is commonly used is git fetch, which allows you to kind of fetch information from your remote repository, so from the GitLab origin remote. And then I can actually check out the branch that Adina was working on, the more comics branch, I can check it out to my local machine, which means I switch from the branch I'm currently on, likely the master branch, I switch to Adina's more comics branch that contains her changes. And you can see here that this switching of the branch was successful. Then actually what I can already do, I can again use the simple ls command to list the files in the directory, and having just pushed the compiling PNG comic before, I notice, oh, there's a new file, interdisciplinary PNG. That sounds very exciting. So what I can already do now, since even on this branch, the annex contents have already been pushed to the Seafile remote that holds the annexed data, I can simply DataLad get this file that doesn't exist yet on my own machine, and I can look at the comic. And actually, I have to say, it's very funny, and usually I'm very strict what is allowed to go into my cartoon collection, and only the most funniest cartoons are allowed to be added to this data set. This is definitely the case here. So what I can do now, and there are again several ways to do it, I can now merge the branch, the more comics branch that Adina created, I can merge it into the main master branch of the data set. I can simply do this through the GitLab web interface. There's also a way to do this locally on my computer through the terminal. So here in this case, unfortunately, I didn't manage to make a screenshot before I actually merged. I was so excited to quickly merge the branch that I just pressed on merge. So usually here on the left side, there would be a green merge button that you can press, and then the Adina's branch will be automatically merged with the master branch. If I want to, I can add comments to it. For example, thank Adina for her contribution. And then if I look at the commit history, so the changes that happen in this data set over time, I can see here, before I merged the branch into the master branch, there is this commit by Adina where she added another fun comic. What I then can actually do back on my local machine in the terminal, I can check out the master branch again, do a DataLad update merge, which kind of gets me the latest changes from the remote repository. And if I do ls again, this interdisciplinary PNG file also exists on my master branch now, since I just merged it into the branch. And we can use this tick tool that Adina also mentioned at some point during the workshop, which again nicely shows the history of changes to this data set. Ta-da! And that was the entire cycle of this collaborative workflow. And we showed you some cool features that mainly come from the, I would say, software development world, where people write issues to propose new changes, and then actually change stuff themselves and propose these changes to the main data set via these merge requests. And this is a very cool way to collaborate with people in a very transparent and organized way. And in our opinion, this can be directly applied to how we work in science as well. All right, but maybe you might feel at this point that this was quite exhausting, and configuring this rclone remote, this was a bit daunting. I'm totally with you. I can tell you, once you get the hang of it, it's actually super easy to do all this configuration, and it won't be such a hassle for you. But you might rightfully ask, isn't there a much easier way to share my data? And just for completeness, we mentioned it several times before, Gin is a very great option to share your data sets and collaborate with people. Actually, I will just briefly show how we can, within the same data set, just simply configure yet another sibling or remote storage solution that we can use with our data set. So I go to the GIN website and create a repository, which I'm not going to show here. Then on my machine in the terminal, I simply add a new sibling for the GIN remote. So again, I do DataLad siblings add -s, or -- name. So I give it a name. In this case, GIN might be a good idea. And I give it the URL. And in this case, again, I'm using SSH. And that way I configure yet another remote. And what I can also do is I just configure yet another publication dependency for my origin GitLab siblings. So I just do DataLad siblings configure to configure the existing origin sibling. And again, I specify the Seafile publication dependency, where I'm actually not sure if this is necessary because it was already configured before. But nonetheless, I do it again just to be safe. And then I add the publish dependency on GIN. And now I actually have two publication dependencies. How amazing is that? And if I do a DataLad push, again to origin, which is our kind of main GitLab repository, DataLad will push the repository structure to GitLab, and it will push the annex content to Seafile, and the combination of both to GIN. And now I have actually another place where my data is stored and can be accessed by collaborators, and that's very neat. Okay, but now with all this amazing DataLad configuration and all these amazing remotes and options we have to share data, you might still say, well, I use DataLad and it's amazing, it's really cool, but still my collaborators, they don't want to deal with DataLad. Then I'm very sorry for you and your collaborators. But don't worry, you can still just let them download the dataset directly from GIN if they want to. So if I have another friend who's not as cool as Adina to use DataLad to get my comic collection, then I can also just point this person to the GIN website, and there's a small download button here on the right, and the person can just simply download the entire data set as a zip file or GIN archive, whatever, and access your data that way. But of course, you need to tell them that they are missing out learning an awesome tool. But I mean, we all know that maybe not everyone we will collaborate with or everyone who wants to access our data wants to learn about DataLad. And I think that's actually also fair. And it's actually nice that through GIN, for example, we can give them the option to access the data in another way, although we have to maybe point out to them that they would lose these benefits of version control and all these functionalities of DataLad that we can that we use when we use DataLad. All right, that was pretty much it about this collaborative workflow. Maybe just as a very quick summary, a very typical collaborative workflow, as we just showed, involves optionally creating an issue to let your collaborators know that you want to propose a change. Then you create a new branch in your data set, make a change, save it, then do all the configuration to be able to push to that data set and push your changes, and you create a merge request, what it's called on GitLab, or a pull request on GitHub, and you can merge all those changes and let your data set grow. All right, that was it for the final section on dataset publication. I should advance. Yeah. Are there any questions? I think I missed out on several. Whoops. I missed out on several comments. Are there any questions? Okay, cool.
I'm just going to quickly go through the 2 questions that are in the shared notes, just to have them answered. So one question is, using DataLad run with a script that takes flags, how would I correctly pass the options? For example, my script gets called by a Python 3 script.py --nperm1000 clf svm. Usually you will be able to just put that string into the run command like that. Just enclose it in quotes and it will work. If you have a shell that maybe escapes things weirdly, you might want to use single quotes in order to have no expansion. But typically, any flags are fine in the DataLad run command. That should work out really well. And then when using HPC, for which you submit jobs rather than run a script on your own machine, what is the best practice to make code reproducible for someone who does not have the HPC option, has to run script on its own machine? So that's a really, really good question. And that's something that we have been working on over the past couple of months, because in the INM7 at the Jülich Research Center, we do those containerized pipelines on a large scale via a batch scheduler. In our case, it's htcondor, and we try to produce fair and digital provenance. So we use DataLad run in parallel with a job scheduler to create a completely fair dataset record of how we preprocessed and analyzed our data. And we have a workflow sketched out here in the DataLad handbook, which is a chapter on computing on clusters. And there is a concrete use case with a walkthrough and a general introduction to it with DataLad-centric analysis with job scheduling and parallel computing. And there we lay out all of the steps that are necessary, first of all, to make job submission and parallel computing work in DataLad datasets, but also highlight a way that is agnostic of the infrastructure that you run it on, the job scheduler that you use it with, because essentially it boils down to, where is it? To having a shell script submitted as a job that does nothing but how you would use DataLad, execute that on a branch and execute that on a compute node on the job that you submit. And that shell script can run on a local machine or on a compute node. So also completely independent of high performance computing clusters or high throughput computing clusters. Okay, let's see.
I think Andre had a comment. He said, I think non-data ladders or non-getters often don't realize how much extra work they inflict on themselves and the collaborators. What would you suggest as an argument to convince them? Just from my own experience, I mean, I can totally resonate with that. I actually don't really have a good answer. I guess, I don't know. For me, there's no other. Do you want to say something about this?
No, I think there's no way to convince people. Like, if they don't want to, they will be always pissed about the work that you inflict on them, and without ever realizing how they can improve their workflow whatsoever. So if the people don't want, you can't make them want to. That's unhealthy, I would say. But what I personally like is that there are a lot of options where I can personally, if I make the decision to use Git or DataLad or any of those tools in whatever workflow I want, where I can still share what I'm doing in a way that's not DataLad specific or DataLad centric, where I can export stuff and put it on the OSF in a view that people outside of DataLad are familiar with. Just download the Gin repository, just export it to Figshare. Everything that's in a dataset is completely unaffected. Basically, it's the same file types. There's you can get stuff out of a dataset if you want to get it out of there, and I think that would be my answer to that. So don't try to convince the people that really don't want to be convinced. That's a painful process. It's easier for you if you stick to the people that are intrinsically motivated to do so. And if you yourself have the feeling that this is something that's beneficial for you, then you can use it in a way that is probably not going to enforce it on everyone that you work with.
Yeah, I agree. There were also some useful comments by Michael and Benjamin that, yeah, just show that you're more productive and let them see, or yeah.
Yeah. Okay.
And maybe I also found that, like Adina said, it's still good to provide other solutions. That's why I also mentioned this option to just download from Gin directly. I mean, there are also other ways. Like for example, before I had to get had from a local data set, then I wanted to send it, I think, to our network server or so, but in an unannexed way. So then I kind of just copied and resolved all the symlinks of the annexed data, and then it was just there without any version control, unfortunately, but still there are all these ways how you can provide people with the stuff they need. And maybe you can just show them interesting tools, and maybe at some point they actually convince themselves that it's a great tool to use and helpful for them. Yeah.
So to use the last 5 minutes, you made it. Congratulations and kudos for being with us throughout this very, very, very exhausting and long and intensive workshop. We have solved, hopefully, questions, but you can get in touch with us later on if you slept over it. And so just as a quick wrap up of what have we done, first and foremost, we lost at least another 0.1 diopters of vision because we stared at a screen for the whole day in our basement. Lennart and I talked so much that we will probably stop talking now for a week if we still have any voice left tomorrow. And if you're not used to working with the terminal, then chances are high that you'll dream of one tonight, and I'm terribly sorry for that. And if DataLad would be cake, then we would have had so much of it today that we would be diabetic. But what else did we do? We had a really intensive day, and Lennart and I hope that we were able to show you some of the ways and tools that we use and how we use DataLad in our day-to-day science, and how that can make science a little bit easier, a little bit more reproducible. And maybe there was something in there that also is useful for you. And beyond DataLad, we've also touched a range of other useful tools and concepts, and we hope that there was something for you in there that you can take with you and read up on or use in your own work. And so you know now a shit ton of things. You have heard about version control concepts, collaborative workflows, different types of provenance, and ways to computational reproducibility. You have heard about software containers and know ways how to use them, places to store and share your data, and how to do it in practice. And if you've never heard about these things before, then oh my God, then this is probably how you currently feel like. And that's completely fine, because it was a lot and it was intensive, and it's always good to have things repeated multiple times. If you didn't understand things, then sleep one night, ask questions. If you hear it again by someone else, then things will become a lot clearer. It's all a slow and step-by-step process, and things are not easy, but in our opinion, they are definitely worth it. And just for a few take-home messages, there are many tools that make research data management and science in general easier, more transparent, and more reproducible. DataLad is one of them. It's flexible and extendable. It can be probably combined with much of what you're using anyways. And if much of what we talked about is new for you, then we have to warn you, no start is perfect. Things are hard to do. It's a complex achievement that you are trying to do. But importantly, there's documentation, especially in the DataLad handbook, and there's a community that you can turn to if you run into bugs, problems, or general questions. If you want to get started with DataLad, then take small steps, take your time, use whatever feature is useful for you. And if you ever need help, have a question, then get in touch, and we're happy to help. And that was it. Lennart, if you want to add something, I definitely want to add a huge thank you to you for this phenomenal collaboration that we had organizing this workshop. This was really, really fun and intensive, and I'm really exhausted, but thank you.
Yeah, I can really just echo basically everything you said, and also return the thank you to you. It was really fun organizing this, and also for the people that supported us. and the Repronym people that are really a very fun cohort to exchange with on reproducibility. And of course, each and every one of you for attending and also providing many interesting ideas and discussions. That was a lot of fun. And yeah, I really just hope that it's useful for you and yeah, you learned something interesting and new.
Yeah, we will make sure to send out links to the published recordings to the email addresses that we have of you, and we can also send the shared notes. And now my voice is actually starting to fade. So I wish you all a pleasant evening. Have a good night. Get some sleep.
Thank you.
Bye.